This will be the second and final section of video notes on circles. Specifically, we're going to look at putting them in a standard form, so using completing the square again to make them match the formula we need. You should have seen all the information on this slide before, but I did want to point out that sometimes they'll ask you to recognize which shape you have, and the best thing you can do is look for whether you have both an x to the second power and a y to the second power in the equation. If both of those variables are being squared, then it has to be a circle that you're looking at. If you only have an x raised to the second power and a y to the first power, or the other way around, you have y squared, but you only have x to the first power, that's how you'll know that the shape you're looking at is actually an equation of a parabola instead. Also notice that the h value is always attached to x. No matter which formula you're looking at, the h value is attached to x, and the k value is attached to y. Because no matter what you're dealing with, we call the h and k values, they're basically special x and y coordinates. So h is always an x coordinate, k is always a y coordinate, whether it's a vertex of a parabola or the center of a circle. So here's the first example similar to what you'll be doing in the assignment. You have to recognize whether it's a parabola or a circle, and you'll notice that in this equation we do have an x squared and a y squared, even though it's not in that factored binomial squared form yet. But since I have both an x squared and a y squared, I already know that this has to be a circle. So we're going to have to set everything up to use completing the square on this thing twice. So I'm going to group together the x terms and leave a space for completing the square. Then I'll group together the y terms. And I'm going to move that constant to the other side of the equation. So I'm going to add 36 to move that over. So since there aren't any numbers in front of the x squared or the y squared, we can go straight into completing the square on this piece. So half of -6 is -3. And then when you square it, that's going to be adding 9. But I have to do that on both sides of the equation. So remember, it's half of b squared. It's the middle number cut in half. And then raised to the second power. Okay, so now if I do the same thing for the y's, half of the middle number is 2. Squared is plus 4, but I have to balance it on the other side of the equation. And now these two terms are going to factor down nicely. It's always going to be the variable and half of the middle number. So half of -6 is -3 squared. For the y part, it's going to be y, and half of the middle number, 4, is a 2 squared. And then if I combine those like terms on the right-hand side, 36 plus 9 is 45, plus 4 more is 49. So we have the equation of a circle, and now I can label that the center is going to be the coordinate h comma k, so that'll be 3 comma -2. Don't forget to change the signs on those. And then the radius, that comes from the square root of the number on the other side. So the square root of 49 is going to be a length of 7. Okay, so one more quick example demonstrating that process. Now again, from looking at this equation, I can see that I have an x squared and a y squared. It doesn't matter where they are. If you see both variables being squared, then it can't be a parabola. It has to be a circle for now. So again, I want to group together the x's, but there's only one x this time. So I'm just going to have my x squared piece over here. I'm going to leave that alone for a second. And then I'm going to come over to the y's. So that would be y squared plus 4y. And I'm going to leave a space for completing the square. And on the other side, I want to take that -9 and I want to move that over. So that's going to be +9 on the other side. So for completing the square on this one, the middle number, if you want to think of it as a 0, that's fine. You're taking half of the middle number, it's still 0. You're squaring it, it's still 0. Basically, the left piece, the x piece, isn't going to have anything for the binomial squared. It's just going to stay as x squared. However, for the y piece, that one does have a b term. So half of the middle number is 2, squared is 4. So I'm adding that number in myself to complete the square. So on the left-hand side, that's just going to stay as an x squared. It doesn't have anything else being added or subtracted to that term. But the y's, in parentheses, this will factor down to be y plus 2 squared. And on the other side, that'll be equal to 13. So what's happened is our h value is a 0. There's nothing being added and subtracted from x. So the h value is 0. The y value is -2. And then for our radius, 13 isn't a perfect square, but that's okay. That just means the radius is the square root of 13. Try not to do decimals. I definitely want you to get into the habit of just leaving things as a radical when you have that as an answer or an improper fraction. So this is our answer. We have our standard form, x squared plus y plus 2 squared equals 13, and you should be able to identify the center and the radius. Just don't forget, if you don't see a number being added or subtracted, it means that that value is a 0, which actually saved us work since we didn't have to complete the square on that part anymore. That's all for the notes today. Thank you.